Okay, well, welcome to Chapter 13, Section 4. Chapter 13.4. I'm going to kind of combine our last two chapters together right now in this problem, where this problem will turn out to yield a system of equations. So let's see if you can copy this problem down. We have a 2 by 2 matrix here being added to a 2 by 2 matrix here, and we're saying that it equals a 2 by 2 matrix here. So if that's true, that means that the first row, first column plus the first row, first column equals the first row, first column. And we can create an equation that says 5m plus n equals 8. If I do that for the other three locations, then I should be able to get some equations that will help me find the variables. Go ahead and put me on pause and see how well you can do. I'll meet you back here in about 5 minutes. Okay, let's see how you did. So after 5m plus n equals 8, we then did 2 plus 6x equals 14. Solve that to get x equals 2. I can't solve the first one because there's two variables, so I'm hoping that there's going to be another equation that has those same two variables. Come down here to 5y plus 6 equals 21. Solve that, I get y equals 3. And then doing the second row, second column, I come up with the equation 3m minus 4n equals 14. Aha! There's my second equation with those two variables. Now I have two equations with two variables, and I can solve that as a system of equations. So I come down here, I group them together. I decide to use the elimination method, so I'm going to multiply this top equation by 4, distribute 4 to all three terms. I end up with 20m plus 4n equals 32. Take the 3m minus 4n equals 14, add straight down, and I get m equals 2. After I know m equals 2, I take that 2, I plug it in for m into this equation right here. Solve for n, I get n equals negative 2. And now I list all my answers in one nice, easy to find location. X equals 2, y equals 3, m equals 2, and n equals negative 2. Okay, well, now that our brains are all warmed up with mathematics, why don't we continue on to the actual lesson? So we're jumping to a 13.4. Hopefully in class yesterday you learned how to find the determinant of a 2 by 2 matrix. If not, please be sure you ask. Our objectives today are twofold. Our objective number 1 is learn how to do scalar multiplication with matrices, just multiplying by a scaled value. And then objective number 2 is to find the product of two matrices. This one is going to require some actual focus and concentration and really processing what it is that I'm saying. So when we get there, make sure that you are in a good place to process and focus. Alright, scalar multiplication, simply put, is multiplying a matrix, A, by a number, K, and then the product is obtained by multiplying each element in matrix A by that number K. K would be known as the scale factor. So, for example, you can see that I have 5, that would be the K value, is being multiplied by this matrix. This is a 3 by 2 matrix, right? Rows by columns, 3 rows, 2 columns, so a 3 by 2 matrix. And in the end, I'm simply going to find my product by multiplying 5 by each element inside this matrix. So what does that look like? Well, that looks like 5 times 2 is 10, 5 times negative 1 is negative 5, 5 times 0, 5 times 12, right, 60 minutes. 5 times negative 7 is negative 35, and 5 times x we can only write as 5x. This is still a matrix, so I'm going to put my brackets around it, and look at that, we ended up with another 3 by 2 matrix. And yes, if you're wondering, the product of the scalar factor by the matrix will be the same dimensions as the original matrix. Okay, do me a favor, take this negative 2y over here in this second example and multiply it by this matrix. This is a 2 row by 4 column matrix, so our answer should be a 2 row by 4 column matrix. Let me just put some blanks in here so we know where to put our answers. This will come in handy later on when I have these blanks also. So take a minute, put me on pause, and fill in the blanks. I want to make sure I give you enough time. Don't want to jump right to it. So I'll fill in the blanks right now. Negative 8y. Ooh, 17, negative 34y. Negative 6y times y, which is, whoa, hello, come back here, which is y squared. So let me get back to my blue. Y squared. Negative 2y times negative 1 is a positive 2y. Now down to the bottom. I love having zeros in my matrices because it's easy. Negative 2y times 5x is going to give me negative 10 xy. We like alphabetical order on that. Come back here. And then negative 2y times negative 50 is 100y. And then negative 2y times 1 over y, well, those y's will cancel, and I'll simply be left with negative 2. All right, I hope you did good on that. If not, please be sure to ask questions tomorrow, because that's it for scalar multiplication. All right, here's our second objective. Multiplying two matrices together, and this needs to be highlighted. This needs to be paid real close attention to. In order to multiply matrices together, the number of columns of the first matrix must equal the number of rows of the second matrix. All right, really important. And here's a little bit further detail. If I multiply an m by n matrix and an n by p matrix, the result, the product of this multiplication, will be an m by p matrix. I know all these variables tend to make it confusing, so let's see if I can help you understand that a little bit better. All right, go a little highlighter here. All right, so what happens is we have number of rows. Oh, that's not what I wanted. We have number of rows m being multiplied by number of so m rows, n columns. Here we have n rows and p columns. So what this is up here is saying, in order to multiply matrices together, the number of columns of the first matrix, rows, columns, so in that case this is n, let me put that here, so columns of the first matrix, that's n, and that must be the same number as the number of rows of the second matrix. So this is my second matrix down here. The number of rows is n. So the number of rows here, number of columns here, this and that must be the same. If that's true, then the resulting matrix will have the number of rows from the first matrix by the number of columns of the second matrix and result in an m by p matrix. So what that means is, if I have, let's go with a nice sharp blue, good. So I want to see if I can multiply this 2, 4, 7, 1, negative 1, 0. So I want to see if I can multiply this matrix by this matrix, 1, negative 2, 4. Is this possible? Well, in order to determine that, you need to identify the dimensions of each matrix. This matrix here is a, hold on, let me move this down, I'm going to need some space. This matrix here is a 2 rows by 3 columns matrix. This matrix here is a 3 rows by 1 column matrix, and lo and behold, the number of columns and the number of rows are the same, so this is a matrix. These are two matrices that we can multiply together. And as a matter of fact, the resulting matrix will have the dimensions 2 by 1. The product will be a 2 by 1 product. So when we're done, our matrix will look like 2 by 1, and there will be a number here, and there would be a number there. 2 rows, 1 column. All right, let's do some multiplying now. Alright, here's an example. I have a 2 by 2 matrix being multiplied by a 2 by 2 matrix. And first thing I need to even ask myself is, can I even do this? Is this even possible? And if I look here, I see the number of columns and the number of rows match. And I also can tell that because they match, my product is going to be a 2 by 2 matrix also. So here I have my 2 by 2 matrix all set up. And let me erase this other stuff and get it out of the way, because here's what I'm about to show you. In order to multiply two matrices together, you multiply the rows of the first matrix. The row of the first matrix. Let me go here with, I'll go crayon. Let's go red crayon. The row of this matrix, I need to multiply by the column of that matrix. Unfortunately, with matrix multiplication, it's not just first element times first element, second element times second element, and so on and so forth. It's actually a bit more complicated than that. And let me walk you through how this looks. And so what I do is I take a look at the first element in this row, and I multiply it by the first element in that row. So I take the 3, multiply it by the 1, and then I add to that the negative 2, the second element in that row, times 7, which is the second element in that column. So you're really multiplying row by column. The first element by the first element plus the second element by the second element. And if there was a third element in this row and a third element in that column, we would multiply those together as well. Okay, that's why the number of columns has to equal the number of rows, and vice versa. So let me take this, put that, and now start putting my final matrix here. So in this first row, first column, I have 3 times 1, 3, plus negative 2 times 7. Negative 2 times 7 is negative 14. 3 plus negative 14, I'm going to get negative 11 in my first spot right there. So let me put some spaces for my other 3 remaining spots. Alright, crayon, let's go blue crayon. Now if I want to find out what goes in the first row, second column, I can get that by multiplying the first row by the second column. And so it's the same idea. I'm going to take the first element in this row, 3, multiply it by the first element in that column, 6. So I end up with 3 times 6 plus, and then I'm going to take, I want the highlighter. Alright, green. The first element in this row, we did that already, 3 times 6, plus negative 2 times 0. So then plus negative 2 times 0, because it's negative 2 is the second element in this row, times 0, which is the second element in that column. Always the row of the first matrix by the column of the second matrix. RC, row of first matrix, column of second matrix. Alright, row by column. Alright, and so let's see, 3 times 6 is 18. 18 plus 0, I get 18 right here. Continuing along to find out what goes in the second row, first column, I multiply the second row by the first column. Same idea. First element times first element, 5 times 1, plus, and then second element by second element, plus 4 times 7. Five times 1 is 5. 5 plus 28 is 33. So 33 goes there. And lastly, for my second row, second column, I am going to multiply the second row by the second column. Shouldn't have used the same color, but hopefully you can stay with me. So